Hey, welcome back, my students. It's so nice to see you on this beautiful day, and I'm really excited to show you how to handle isotopes. So what I mean by that is when I ask you how many protons, neutrons, and electrons do two different isotopes have, you'll be able to answer that by the end of this video. Don't forget that I have a couple of practice questions that are associated with this, and those will be in your team's notebook. As a quick review, I just want to let you know that when I'm dealing with protons, neutrons, and electrons, I have protons with a specific charge, electrons have a specific charge, and neutrons do not have any charge. And when I say that protons and neutrons have mass, but electrons do not, I don't actually mean that electrons have no mass. All matter has mass. But what I am saying is that relative to those other two subatomic particles, electrons just don't even register. So these are your values that you're going to be using. Let's think about how it works. Okay, when I'm talking about something that's an isotope, all atoms of specific elements are going to have isotopes. It's very natural for several different kinds of isotopes of one element to exist in the natural world. Some isotopes are very, very common, and some are very, very rare. The one that I'm going to be talking about, for example, is carbon-12, and then later we'll talk about carbon-14. When I say carbon-12, what I'm trying to tell you is that my carbon-12 isotope has a mass number of 12. When I talk about the mass number, what I mean is that is the addition or the total value of the mass of protons and neutrons. So let me show you that. My mass number is going to be equal to the value of my protons and the value of my neutrons put together. So the mass number for carbon-12 is going to be 12. So then the next question is, how do I figure out how many protons and neutrons I have? Here we go. The first place I'm going to look for any information is going to be the periodic table, and on the periodic table I'm going to have a whole bunch of data about every element that we've ever discovered. I'm going to zoom in on carbon. Right here, and then when we zoom in I'll have all those values for you. Here's a copy of the entry for carbon from my periodic table. So I have my atomic number, I have the symbol for the element, I have the full name of the element, and I have the average atomic mass here. Remember from my previous video that the number of protons is always going to be equal to my atomic number. And I have the mass number from the name of the isotope. Carbon-12 tells me that my mass number for this isotope is 12. All right, to solve for the number of neutrons that I have, all I have to do is solve for n. Perfect. So now I know that for an atom of carbon-12, I'm going to have 6 protons and 6 neutrons. And in terms of electrons, this is a neutrally charged atom, so the number of protons and neutrons has to be the same. I'll write it down. Great. I've taken care of that. Now let's talk about carbon-14. All organisms have carbon in their bodies, and all organisms are going to have a little bit of each of these isotopes in them. In fact, what we do is we use the ratio of carbon-14 to carbon-12 to figure out how long it's been since an organism died. We determined that an atom of carbon-12 is going to have 6 protons, 6 neutrons, and 6 electrons. And if we were to change the number of protons in an atom, we wouldn't really be dealing with the same element anymore. So we know that the number of protons in carbon-14 is also 6. And we know that the number of electrons in carbon-14 is also 6 because both are neutral atoms. If I say atom, I mean neutral. If I say ion, I mean charged. And that's something we're going to talk about in our next video. Remember that the name of my isotope always includes the mass number. So the mass number for carbon-12 was 12, and the mass number for carbon-14 was 14. Both of them have 6 protons. And to figure out the number of neutrons that I have, all I have to do is solve for n in each instance. So what I really want you to remember when you're dealing with isotopes of something is that it's the number of neutrons that's different. So in the case of carbon-12, I'm going to have 6 neutrons, and in the case of carbon-14, I have 8, which means carbon-14 is just a little bit heavier than carbon-12. I have one last example for you. That example is going to be for boron-10 and boron-11. If you think you can already tell what the neutron difference is in them, you're probably right, but let's work through it and make sure that we know for sure. Let's go over to the periodic table and go look at it. Here's my periodic table again, and boron is right here, number 5, right next to carbon. I have an atomic number of 5, symbol B, and looks like mass, average atomic mass of 10.81. Remember that 10.81 means that most of the isotopes in existence are going to be like boron-11 with some boron-10 and maybe a couple other ones that really aren't that common. That's just really my way of making sure that you know that when I'm asking you general questions about these things, you're rounding. What you need to know for each of these is that the isotope name is a reference to its mass number, so my boron-11 has a mass number of 11, and my boron-10 has a mass number of 10. Then the next thing we're going to do to figure out how much of each of my subatomic particles is in here is that the mass number is equal to the number of protons and the number of neutrons, because those have a lot more mass than electrons. Okay, so I know that my mass number for boron-10 is 10, and my mass number for boron-11 is 11, and I know that the number of protons is going to be 5, because if I change the number of protons, I'm not dealing with boron anymore. Then I solve for the number of neutrons. Five and 5, 5 and 6, and then they are neutral atoms, so 5 and 5, or else they become ions, and that's what we're going to talk about next. Thanks for watching. See you in the next video.